What is it you are truly afraid of when the lights go out? Is it merely the absence of photons, the simple lack of visual information? Or is it something deeper, a fear far older than our cities, a primal drumbeat echoing from a time when our ancestors understood that the coming of night meant the coming of the unseen predator? In that ancestral darkness, our most vital sense was rendered useless, and we were reduced to pure vulnerability, our survival hanging by the fragile thread of hearing and instinct. That terror is a ghost in our genome, a whisper in our DNA that has never truly been silenced, no matter how many electric suns we invent to hold it at bay. It is the fear of the unknown, the dread of powerlessness, the chilling realization that the universe does not require our consent to simply turn off the sky. For millennia, this profound anxiety has been the fertile soil from which our darkest myths and most terrifying prophecies have grown. We have given it names, woven it into the fabric of our cultures, and projected it onto the vast, silent canvas of the cosmos. Across civilizations separated by oceans and epochs, a strangely persistent and recurring vision emerges, a shared nightmare of a world cloaked in an unnatural, suffocating blackness. In the volcanic visions of the Norse, it was the Fimbulwinter, 3 years of biting cold and perpetual twilight preceding the final cataclysm of Ragnarok, when the wolf skull would finally devour the sun and its sibling Hati would swallow, the moon plunging the 9 realms into an abyss of absolute darkness. The ancient Egyptians, whose entire civilization was a hymn to the sun god Ra, conceived of their ultimate horror in the form of Apep, the serpent of chaos, an eternal enemy who sought every night to consume Ra's solar barge as it journeyed through the underworld, threatening to prevent the dawn. Imagine the terror of a people whose very existence depended on the predictable rhythm of sunrise and sunset, contemplating a reality where that rhythm was broken forever. This wasn't just a story, it was a cosmic battle fought anew every 12 hours, a constant struggle against the forces of non-existence. The idea that darkness was not just an absence but an active, malevolent force became a cornerstone of human psychology. This archetype of a world-ending shadow is not a relic of a forgotten past. It is a story we cannot seem to stop telling ourselves. You can find its echo in the Hindu scriptures, which speak of the pralaya, the dissolution of the cosmos into a dark, formless ocean at the end of an age. You can see it in the Mayan Popol Vuh, with its tales of flawed earlier creations of humanity being extinguished by great floods and obscuring darkness before the true people of maize could emerge. And most potently, most directly, it crystallized into a specific haunting prophecy that has resonated through the ages, the 3 days of darkness. This phrase rooted in the biblical account of the 9th plague of Egypt, a darkness so profound it could be felt, a smothering blanket of shadow that fell only upon the Egyptians and lasted for 3 excruciating days, has been adopted and adapted by mystics and prophets for centuries. It became a staple of eschatological belief, a prophesied divine punishment, or a sign of the end times, a period of terrifying blindness where the laws of nature would be suspended and the veil between worlds would grow thin. This wasn't just a long night. It was a fundamental rupture in the fabric of reality, a time when the sun itself would refuse to shine upon the earth. For generations, it remained a powerful, terrifying, but ultimately abstract concept, a story whispered in hushed tones, a fable for a distant and uncertain future. Then came the 21st century. The old world of myth and prophecy collided with a new global nervous system, the internet. In this new ecosystem, information, and more importantly misinformation, no longer trickled down through generations. It exploded across continents in an instant. Fear, that most ancient and contagious of human emotions, had found its ultimate amplifier. And in the early months of 2020, this global network found a new focal point for its oldest anxiety. Its name was Comet C, 2019 Y4, but the world would come to know it by a name that seemed ripped from the pages of mythology itself, Atlas. Discovered by the Asteroid Terrestrial Impact Last Alert System, Atlas was at first an object of pure scientific wonder. It was a faint smudge of light, a long-period comet on a grand sweeping journey in from the Oort cloud, the most distant frozen frontier of our solar system. Astronomers were thrilled. As it raced toward the inner solar system, it began to brighten at an astonishing, almost unprecedented rate. Its coma, the ethereal cloud of gas and dust surrounding its icy nucleus, swelled to a colossal size, at one point rivaling the diameter of Jupiter. It was on a trajectory that would carry it remarkably close to the Sun, and for a breathless moment, the astronomical community dared to hope. They speculated that Atlas could become a great comet, a spectacular celestial event visible to the naked eye even in daylight, a once-in-a-generation spectacle of cosmic beauty. But where science saw beauty, the digital world began to see a portent. The comet's dramatic brightening, its mythological name evoking the Titan who held up the heavens, and its path toward our life-giving star, created a perfect storm of apocalyptic speculation. The ancient fear that ghost in our DNA had found a new vessel. Suddenly, the 3 days of darkness was no longer an ancient prophecy. It was a breaking news headline propagated through YouTube thumbnails and viral social media posts. The algorithm, blind to truth and optimized for engagement, began to feed the fear. The narrative shifted with terrifying speed. Atlas was no longer a beautiful cosmic visitor. It was a monstrous harbinger of doom. The whispers started online in forums and comment sections, then grew into a roar. Elaborate pseudo-scientific theories emerged, claiming the comet was not a comet at all, but a piece of a rogue planet or an alien ship, or a harbinger designed to trigger a polar shift. The most pervasive and powerful theory, however, was the one that tapped directly into that primal fear of the dark. The claim was that Atlas's vast and growing tail, filled with thick sun-blocking dust, would perfectly intersect with Earth's orbit. It would cast a shadow over the entire planet, not for a few minutes like a solar eclipse, but for 3 full days. The prophecy was being fulfilled not by a supernatural force, but by the predictable mechanics of orbital physics. It was a story perfectly tailored for our anxious age. It combined a kernel of scientific reality, a real observable comet with a deep-seated archetypal terror. Videos with dramatic synthesized music and bold capitalized text racked up millions of views. Articles were written, memes were created, and a genuine palpable panic began to set in for a small but vocal segment of the global population. They pointed to the comet's green hue as an ill omen, a sign of its supposedly toxic nature. They took its brightening not as a sign of its volatile composition, but as proof of its immense world-ending size. Every new piece of data from astronomers was twisted and reinterpreted through a lens of fear. The scientific community, accustomed to speaking in careful, nuanced language, found itself struggling to shout over the deafening noise of digital hysteria. They tried to explain the realities of cometary physics, the near impossibility of a comet's tail, which is more diffuse than the best laboratory vacuum on Earth, ever blocking the sun in any meaningful way. They tried to explain that the comet's trajectory, while fascinating, posed no threat of intersection, but in the battle between reassuring complex fact and terrifying simple fiction, fiction often has the upper hand. The fear was no longer about the comet itself. It was about what the comet represented, a loss of control, a cosmic threat beyond our comprehension, and the coming of an eternal night. And then, as suddenly as it had brightened, Atlas began to fade. The celestial monster that was meant to blot out our sun began to die. High-resolution images from telescopes like Hubble revealed the truth. The comet's furious brightening wasn't a sign of its strength, but of its death throes. The intense heat of the approaching sun was too much for its fragile icy nucleus. It was breaking apart, fragmenting into a cascade of smaller, glittering pieces, a celestial ghost dissolving back into the darkness from which it came. By the time it reached its closest approach to the sun, Comet Atlas was no more. It was a string of cosmic rubble, a beautiful but harmless shower of dust and ice. There was no collision, there was no planetary shadow. The sun rose as it always does. The 3 days of darkness never came. The prophecy, it seemed, had failed. For the world at large, the story was over a strange footnote in a year already filled with anxiety. The digital prophets fell silent or moved on to the next impending apocalypse, their audience scattering like dust in the solar wind. The panic subsided, leaving behind only a trail of deleted posts and a lingering sense of embarrassment. But to dismiss the Atlas phenomenon as mere foolishness is to miss the profound and urgent question it unearthed. The fear was misplaced, the threat was imaginary, but the underlying vulnerability it exposed is very, very real. The episode proved that our ancient terror of a world without a sun is not a relic of the past. It is dormant, waiting for a trigger. It revealed how quickly we, as a species, can be swayed by narratives that confirm our deepest anxieties, even in the face of overwhelming scientific evidence. Atlas was a false alarm, a shadow play projected onto the cosmos, yet it forces us to confront the central thesis of our journey together. We have now seen how myth and misinformation can create the illusion of a threat. But what happens when we strip away the prophecy, the panic, and the pseudoscience? What remains when we look at this primal fear with the cold, clear eyes of physics and cosmology? The question is no longer if times we will believe that the world will end in darkness, but whether the universe itself could actually make it happen. Is the concept of prolonged global darkness the terrifying core of the 3 days of darkness myth scientifically plausible? We must now pivot from the realm of human belief to the stark realities of the cosmos. The universe is a place of unimaginable violence and scale, a realm where events that dwarf human comprehension are not aberrations but the norm. Could an object far larger and denser than a fragile comet, like a rogue planet wandering starless through the interstellar void, drift into our path and cast a permanent eclipse? Could the impact of a civilization-ending asteroid kick so much debris into our atmosphere that it creates an impact winter, a suffocating shroud of dust that blots out the sun for years, even decades? Perhaps the greatest threat comes not from a foreign object, but from within our own planetary system. What if a supervolcano, a geological monster slumbering beneath our feet, were to erupt with a force 1,000 times greater than any in recorded history, vomiting enough ash into the stratosphere to create a volcanic night that could last for a generation, causing the collapse of global agriculture and the fall of civilization? Or could the threat be even grander, originating not from a rock or from our planet, but from the very stars themselves? Are there stellar events, like the cataclysmic explosion of a nearby supernova or a gamma-ray burst, that could damage our atmosphere so profoundly that it becomes opaque? The fear of darkness is ancient and irrational, but the question of its possibility is a modern and scientific one. The saga of Comet Atlas was a dress rehearsal, a test of our relationship with cosmic threats, both real and imagined. Now the real investigation must begin. We must journey past the edge of myth and into the heart of the celestial machine to ask a question that haunts the dreams of civilizations. Is the sun's light a permanent gift, or merely a temporary reprieve from an inevitable and final darkness? What is the oldest fear in the human heart? It is not the fear of the predator in the grass, nor the venom in the fang. Those are fears of the immediate, of the flesh. The most profound terror, the one that has echoed down through every civilization we have ever built, is the fear of a silent, indifferent sky finally turning against us. It is the dread that the one constant in our lives, the giver of light and warmth and life itself, might one day be taken away, that the sun, our steadfast cosmic anchor, could simply vanish. This anxiety is a dormant gene in our collective psyche, a primordial memory of a time before fire, when darkness meant the end of everything. A world plunged into an absolute unending night is a concept so fundamentally alien to the rhythm of our biology, so contrary to the cycles that govern our planet, that we have woven it into our most sacred and terrifying stories. We gave it a name, a chillingly simple prophecy that whispers from the pages of ancient texts and the depths of our own imaginations, the 3 days of darkness. It is a story we have told ourselves for millennia, a myth waiting for a messenger. And in the final days of 2019, from the cold, impartial darkness of deep space, we began to believe a messenger was finally on its way. This ancient narrative of cosmic abandonment did not emerge from a vacuum. It is the culmination of a long and troubled relationship we have had with the heavens. For our ancestors, the sky was a place of divine order, a celestial tapestry woven with predictable, reassuring patterns. The sun rose and set with unflinching regularity. The moon waxed and waned on a schedule you could set your life by. The stars, fixed in their constellations, wheeled overhead in a grand eternal procession. This cosmic clockwork was the ultimate proof of a stable, understandable universe. But into this perfection from time to time an intruder would appear, an uninvited guest, comets. They were unlike anything else in the night sky. They adhered to no known rules, appearing without warning from the depths of the void. They were not points of light, but ghostly apparitions with long, ethereal tails that stretched across the heavens like a divine smear, a celestial wound. They didn't move with the stately grace of the planets. They blazed across the constellations, lingered for weeks or months, and then disappeared as mysteriously as they had arrived. Imagine yourself standing in a field 2,000 years ago. You have no telescope, no understanding of orbital mechanics. Your world is one of earth, water, and that perfect, predictable sky. Then one night a new star appears, a star with a tail, a star that weeps. What else could you conclude but that it was an omen, a message from the gods, and rarely, if ever, was the message presumed to be good? This visceral reaction is etched into our history. The arrival of what we now call Halley's Comet in 1066 was immortalized in the Bayeux Tapestry, a terrifying portent looming over King Harold just before the Norman invasion and his own death. The Great Comet of 1680, a spectacular sight that arced across the European sky, was widely interpreted as a harbinger of divine wrath, sparking panic and religious fervor. For centuries, these icy wanderers were blamed for plagues, for the death of kings, for famine and war. They were celestial scapegoats, the perfect canvas onto which we could project our anxieties about a chaotic and unpredictable world. They were proof that the divine order could be broken, that the heavens were not immutable, and if the heavens could change, if a ghostly sword could suddenly appear among the stars, then what other cosmic certainty might one day fail? What could be more terrifyingly uncertain than the rising of the sun? This deep cultural programming is the soil in which the prophecy of the 3 days of darkness took root. The most famous allusions trace back to the biblical book of Exodus, which describes a plague of darkness descending upon Egypt, a darkness which may be felt so absolute that they saw not one another, neither rose any from his place for 3 days. This wasn't merely a cloudy sky, it was a supernatural event, a physical manifestation of divine power, a tool to humble the most powerful empire on earth. The concept echoes again in the book of Revelation with its apocalyptic visions of the sun becoming black as sackcloth of hair and the moon turning to blood. These weren't scientific predictions. They were powerful symbolic metaphors for cosmic upheaval, for a time when the fundamental laws of nature would be suspended. But the human mind has a way of turning metaphor into literal expectation. Over centuries, these scriptural seeds grew into a complex mythology, a persistent and detailed prophecy whispered through religious and esoteric circles. It speaks of a time of judgment and renewal, a planetary cleansing that would be heralded by a period of total, terrifying blackness. It's a story that promises both doom and salvation, a narrative of profound transformation that requires an equally profound catalyst. For a very long time, the identity of this catalyst remained a mystery, a subject of endless speculation. Then came the age of modern astronomy, and we built new eyes to watch the sky, eyes that saw everything, eyes that one night saw a faint smudge of light moving where no smudge should be. On December 28, 2019, the world was blissfully unaware. The holidays were ending, a new year was dawning, and the great cosmic clock seemed to be ticking along just as it always had. But in observatories on the volcanic slopes of Hawaii, a silent watchman was on duty. This was not a human observer peering through an eyepiece, but a sophisticated automated system, the Asteroid Terrestrial Impact Last Alert System, or ATLAS. Its mission is stark and vital to scan the entire observable sky every 2 nights. A digital sentinel searching for moving objects specifically for asteroids that might pose a threat to Earth. It is our planetary burglar alarm. On that night, the system software flagged a new object in the constellation Ursa Major. It was given a sterile, bureaucratic name C, 2019 Y4, The sea designated it as a long-period comet, a visitor from the impossibly distant Oort cloud, the frozen frontier of our solar system. The initial calculations showed it was no threat. It was faint, distant, and on a trajectory that would bring it swooping around the sun before flinging it back out into the void, not to be seen again for over 5,000 years. For the astronomical community, it was another interesting but routine discovery. Another tiny data point in the immense catalogue of the cosmos. But then something unexpected began to happen. As C 2019 Y4, now given the more accessible name Comet Atlas, began its long fall toward the sun, it started to brighten. And not just by a little, it brightened dramatically at a rate that defied all predictions. By March of 2020, its brightness had increased by a staggering factor of several thousand. Astronomers, both professional and amateur, were captivated. This was no longer a routine discovery. The comet was behaving like a true celestial peacock, unfurling a magnificent coma of gas and dust as solar radiation began to vaporize its icy surface. The calculations were thrilling. If it continued on this trajectory, if it held together as it rounded the sun, Comet Atlas was on track to become one of the most spectacular comets of the 21st century. It could potentially become a great comet, an object so brilliant it would be easily visible to the naked eye even in daylight, its tail a luminous ribbon painted across the evening sky. For a world just beginning to grapple with the unnerving reality of a global pandemic, the prospect of such a breathtaking celestial spectacle felt like a gift, a moment of shared wonder and cosmic perspective. It was a reminder of a universe vast and beautiful, operating on scales that dwarfed our terrestrial concerns. The excitement was palpable. The media picked up the story. Stargazers around the world trained their telescopes on the approaching visitor, watching as it grew brighter with each passing night. We were all looking up, waiting for the show to begin. We were waiting for a miracle. What we got was something else entirely. In early April 2020, at the very peak of anticipation, the miracle began to unravel. Observers started to notice that the comet's central core, its nucleus, was no longer a sharp stellar point. It had become elongated, fuzzy. The brilliant jewel at the head of the comet was losing its cohesion. Then the Hubble Space Telescope was turned to investigate its powerful vision, cutting through the haze of the coma to see the truth. The nucleus was not just fuzzy. It had shattered. The single solid heart of Comet Atlas had disintegrated into a cascade of smaller icy fragments. Like a ship of glass hitting a reef, the traveller from the Oort cloud had been broken apart by the growing thermal and gravitational stresses of its journey toward the sun. For the astronomers, it was a moment of scientific fascination tinged with disappointment. The dream of a great comet was over. The fragments would continue along the same orbital path, but they would spread out and fade, a ghostly funeral procession rather than a triumphant celestial parade. The science was clear. The comet's volatile, loosely packed structure simply couldn't withstand the sun's relentless celestial blowtorch. It was a common fate for comets making their first perilous journey into the inner solar system. Case closed. A beautiful attempt, but ultimately a failure. But outside the world of astronomical journals and observatory data, a very different story was taking shape. For millions of people watching online, the fragmentation was not an ending. It was a beginning. It wasn't a natural death. It was a deliberate transformation. The official explanation, the one grounded in physics and observation, was discarded. In its place, a new, far more terrifying narrative began to spread with viral intensity across social media platforms, forums, and video sharing sites. The fragments this new myth proclaimed were not debris. They were a fleet. They were a smokescreen. The comet hadn't disintegrated. It had cloaked, shedding its outer layers to reveal something hidden within, or to intentionally create a vast cloud to obscure our view. The mundane designation C 2019 Y4 was cast aside, and the ancient prophecies were invoked. This, they insisted, was the true harbinger. This was the catalyst for the 3 days of darkness. The narrative was meticulously, if pseudoscientifically, constructed. The cloud of fragments, which astronomers saw as a diffuse and rapidly dimming collection of dust and ice, was reimagined as a cohesive, targeted weapon. Its purpose? To spread out along its orbit, and at the precise moment it crossed the plane between the Earth and the Sun to create a shadow so vast and so complete that it would block all sunlight, plunging our planet into the prophesied period of absolute blackness. A strange and unprecedented schism occurred. On one side, you had the global astronomical community using the world's most advanced instruments to track the faint fading spectres of what was once a promising comet. They produced images, charts, and spectrographic analyses, all showing the reality of a disintegrating ball of ice and rocket's light signature diminishing with each passing day. On the other side, you had a burgeoning digital movement armed with grainy cell phone videos of lens flares, misidentified planets, and out-of-focus stars. They interpreted every atmospheric phenomenon, every satellite glint, every contrail as proof of the approaching object or its accompanying fleet. A stark contrast emerged between two realities. One was a universe governed by the cold, elegant laws of orbital mechanics and thermodynamics. The other was a universe of intention, of conspiracy, of cosmic events unfolding according to a pre-written apocalyptic script. Comet Atlas was no longer a subject of scientific inquiry. It had become a symbol, a celestial Rorschach test. For scientists, it was a fascinating case study in cometary physics. But for a growing number of people around the world, it was the fulfillment of a dark and ancient promise. It was the physical manifestation of our oldest fear now, given a name, an orbit, and an estimated time of arrival. The question that consumed so many was no longer times if times it would happen, but times when asterisk. And so the ghost of Comet Atlas continued its journey, its physical presence fading into near invisibility, while its mythological presence grew to monstrous proportions. Every new piece of data released by NASA or the European Space Agency was not seen as a clarification but as part of a cover-up. Every scientific explanation was dismissed as disinformation designed to quell a panic that the world's governments secretly knew was justified. This phenomenon highlights a profound chasm in our modern world, a gap between the power of our scientific instruments to observe the universe and the power of the human mind to interpret what it sees through a lens of fear, hope, and deeply ingrained belief. We can photograph a comet billions of kilometers away, we can analyze the chemical composition of its gas, we can predict its path to within meters. Yet for some, none of that matters. The data is irrelevant when confronted with the emotional weight of a 2,000-year-old story. The broken remnants of Atlas became a perfect metaphor for our fractured information age, a single event observed by all but understood in completely different, mutually exclusive ways. A simple astronomical event had spiraled into a global conspiracy, reigniting a primal fear that science had long since believed extinguished. It forces us to ask a difficult question. Why this comet? Out of the thousands of objects that streak through our solar system, why did this one, a relatively minor comet that ultimately failed to deliver on its initial promise, become the vessel for such an immense and terrifying prophecy? Was there something genuinely unique about its trajectory, something unusual about its debris field, that even if it couldn't block, the sun could trigger some other unforeseen effect? Or are we as a species simply so primed by our own anxieties that we are now desperately searching the heavens for something, anything, to validate our deepest fears, projecting our own inner darkness onto the cold, silent canvas of the cosmos? The search for that answer takes us beyond the realm of prophecy and into the hard, unforgiving reality of celestial mechanics. We must follow the fragments, so the fear is ignited, a primal terror sparked by a whisper from the void. We have seen the phantom comet 3IATLAS, a celestial spectre drifting through the collective consciousness of our digitally connected world. The prophecy, ancient and modern, is simple and stark. It will come between us and our star, casting a pall of darkness for 3 days, an event heralding an end or a grim new beginning. It is a story that resonates with a fear buried deep in our DNA, the ancestral dread of the sun failing, of the long night that never ends. But now we must step away from the prophecy, away from the fear, and into the cold, clarifying light of physics. We must ask the hard question: could this cosmic wanderer, or any object like it, truly be the agent of such a global eclipse? To answer this, we must first confront the tyranny of scale, a concept our minds evolved to gauge the threat of a predator in the grass struggle to comprehend. The Sun, our Sun, is a thermonuclear furnace so vast that 1.3 million Earths could fit comfortably inside it. Its diameter stretches nearly 1 million miles across. It is the unwavering gravitational anchor of our entire solar system, a behemoth of incandescent plasma. Now consider the nucleus of Comet Atlas before it began to disintegrate. It was at its most generous estimate, perhaps a few kilometers across. Even if we imagine its most spectacular intact form, placing it against the Sun is not like placing your thumb over a distant light bulb. It is like trying to eclipse that same light bulb with a single grain of dust held a mile away. The mismatch in size is so profound, so absolute, that the very premise crumbles under the weight of cosmic geometry. For a true lasting eclipse, an object must not only be large, but it must have a significant angular diameter in our sky. Our own moon, 250,000 miles away and 2,000 miles wide, performs this delicate ballet perfectly. It is 400 times smaller than the Sun, but it is also, by a stunning cosmic coincidence, 400 times closer. This celestial geometry allows its disk to just barely cover the Sun's, creating the fleeting, magnificent spectacle of a total solar eclipse, a darkness that races across our planet's surface for mere minutes. Comet Atlas, even at its closest approach to Earth, was still tens of millions of miles away. Its tiny, fragmented core would have appeared as little more than a pinpoint of light through a powerful telescope, a firefly against a cosmic bonfire. To block the Sun from our perspective, it would have needed to be unimaginably vast, or so terrifyingly close that an eclipse would be the very least of our concerns. An imminent, cataclysmic impact would be the real headline. But the myth persists, perhaps envisioning not the tiny nucleus but the comet's magnificent tail, its coma as the true veil of darkness. Surely this vast, shimmering cloud of gas and dust stretching for millions of miles could act as a celestial curtain. Here we must move from the physics of scale to the science of substance. A comet is not a solid, opaque object like a planet or a moon. It is a relic from the birth of our solar system, a loose agglomeration of ice, dust, and frozen gases, a dirty snowball as it's famously known. As it ventures near the Sun, this fragile artifact begins to sublimate. The Sun's radiation acts as a celestial blowtorch, vaporizing the ices and releasing the trapped dust. This material forms the coma, the glowing atmosphere around the nucleus, and is then pushed away by the solar wind and radiation pressure, forming the iconic tail. And here lies the paradox. The very thing that makes a comet visible also makes it incapable of blocking light. The tail of a comet is one of the most ethereal, tenuous phenomena in the entire solar system. It is a near-perfect vacuum, far less dense than the thinnest wisp of smoke from a campfire. While it may look bright and substantial from millions of miles away, that's only because its tiny particles are magnificently efficient at scattering sunlight, glowing like a cosmic phantom. If you were to fly a spacecraft through the densest part of a comet's tail, you would likely not even notice. The particles are so spread out, microns in size, and meters or even kilometers apart, that they pose almost no physical obstacle. Trying to block the Sun with a comet's tail would be like trying to build a dam with a cloud of mist, or stop a hurricane with a fishing net. The light of the Sun would stream through it almost entirely unimpeded, its passage only slightly dimmed in a way no human eye could ever detect from Earth. It is not a shroud. It is a shimmering illusion, a ghost of matter spread impossibly thin across the vacuum of space. Finally, we come to the most rigid and unforgiving arbiter of cosmic events, orbital mechanics. The paths of celestial bodies are not random. They are governed by gravity scribed into the fabric of space-time with mathematical precision. We knew the trajectory of Comet Atlas from the moment of its discovery. We knew its inclination, its speed, its closest approach to both the Sun and Earth. Its path was a sweeping, predictable arc through the inner solar system, a journey that never once brought it into the precise razor-thin alignment required to cast even a fleeting shadow upon our world. The solar system is not a crowded room. It is a vast three-dimensional ocean. Planets orbit largely on a flat plane, the ecliptic. Comets, especially those from the distant Oort cloud like Atlas, often arrive on highly inclined orbits, diving down from above or swooping up from below this plane. To orchestrate a 3-day eclipse would require a cosmic conspiracy of impossible proportions. An object of planetary size moving on the exact same plane as Earth, at the exact same orbital speed, perfectly positioning itself between us, and the Sun, and holding that position for 72 hours. Such an object does not exist. It cannot exist. The laws of celestial motion, immutable and absolute, forbid it. The 3 days of darkness from a passing comet is not a plausible future. It is a physical impossibility, a ghost story told about the heavens. And yet, the fear feels real for a reason. The instinct that darkness times can times fall, that our luminous sky is a fragile ceiling that can be shattered, is not born of pure fantasy. It is a primal intuition, a species memory of catastrophes past. The myth of the comet gets the agent of destruction wrong, but the terror of a world plunged into an artificial unending night is not misplaced. The potential for such a global cataclysm is terrifyingly real. We have simply been looking in the wrong direction. The true threats are not wisps of ice and dust from the outer solar system. They are far more powerful, more elemental. One is a monster stirring deep within the crust of our own planet. The other is a cosmic hammer, a threat of such violence it rewrites the book of life. To find the real darkness, we must first turn our gaze downward into the fiery heart of the Earth itself. Beneath some of the most beautiful landscapes on our planet, the geyser basins of Yellowstone, the serene waters of Lake Toba in Sumatra, lie chambers of unimaginable power. These are not mountains that erupt. They are entire regions of the Earth's crust that have the potential to unzip, to fail catastrophically. They are supervolcanoes. A super eruption is not a geological event. It is a planetary one. The sheer explosive force dwarfs the entire nuclear arsenal of humanity combined. But it is not the immediate blast or the colossal lava flows that pose the greatest threat to global civilization. It is what the eruption hurls into the sky. An event on this scale would inject hundreds, even thousands of cubic kilometers of ash, rock, and gas into the atmosphere. The most critical component for a global winter is not the ash, which is heavy and falls out of the sky relatively quickly, but a chemical compound you know from the smell of a struck match, sulfur dioxide. The volcanic plume, powered by the planet's internal heat, would not just punch through the troposphere, the layer of weather we live in. It would rocket deep into the stratosphere, the serene, stable layer above. Up there, above the clouds and the rains that would normally wash pollutants away, the sulfur dioxide begins a sinister transformation. Through a series of chemical reactions with water vapor, it forms a fine mist of sulfuric acid aerosols. These droplets are microscopic, far too small to see individually, but their collective effect is catastrophic. They do not block the sun, they reflect it. Each tiny aerosol acts as a microscopic mirror. 1 billion of them become 1 billion mirrors. 1 trillion of them spread across the globe by stratospheric winds form a planetary shroud. This shimmering, semi-transparent veil begins to turn back the sunlight, casting it back into the void before it can ever reach and warm the ground. The effect is not an instantaneous blackout. It is something perhaps more insidious, a slow grinding and persistent dimming. The sky might take on a milky, perpetually overcast appearance. The sun, when visible, would be a pale, weakened disk. Daylight would be reduced to a permanent, dreary twilight. Within months, the global average temperature would begin to plummet, not by 1 or 2 degrees, but potentially by 5, 10, or even more. This is the volcanic winter. Growing seasons would fail not just for 1 year, but for many, as the aerosols can remain suspended in the stratosphere for a decade or longer. The intricate web of global food production would disintegrate into chaos. We have seen previews of this. The 1,815 eruption of Mount Tambora in Indonesia, a fraction of a true super-eruption, led to 1,816's year without a summer, causing crop failures and famine across the northern hemisphere. Further back, some 74,000 years ago, the Toba super-eruption is hypothesized to have plunged the Earth into a volcanic winter lasting 6 to 10 years, creating a genetic bottleneck that nearly wiped out our fledgling human species. This is not a 3-day darkness. It is a decade of twilight, a slow-motion catastrophe that starves civilizations, rewrites ecosystems, and pushes life to the very brink of extinction. It is a darkness generated from within a planet, turning its own breath into a veil to suffocate the life on its surface. But the Earth is not the only architect of its own potential doom. The heavens do hold a genuine agent of global darkness, and it is an event of such terrifying violence it makes a supervolcano seem gentle by comparison. The threat is not a passing comet, but a direct impact from a large asteroid or cometary nucleus, a solid body kilometers wide traveling at hypersonic speeds. This is not a subtle dimming. This is the sky falling in the most literal sense. To understand this mechanism of darkness, we must journey back 66 million years to the final day of the dinosaurs. When an asteroid estimated to be 10 kilometers wide, the size of Mount Everest, slammed into the shallow sea of what is now the Yucatan Peninsula, it did not merely strike the Earth. It delivered a blow of such inconceivable energy, equivalent to billions of atomic bombs, that it fundamentally altered the planet. The darkness that followed was not caused by the asteroid itself eclipsing the Sun during its final fiery descent. The darkness was made of the Earth itself, weaponized against its own inhabitants. In the first moments of impact, an immense volume of the planet's crust, rock, soil, water was vaporized and pulverized, ejected back into and even beyond the atmosphere on ballistic trajectories. Trillions of tons of superheated material were blasted into space only to be pulled back down by gravity. As this rain of molten rock and glass re-entered the atmosphere all over the globe, friction heated the air to temperatures comparable to a pizza oven. The sky itself would have glowed with a dull, terrifying red. This intense pulse of thermal radiation ignited global firestorms, burning vast swathes of the planet's forests and grasslands. And here the true engine of darkness was forged. The immense quantity of soot and ash from these continent-spanning fires, along with the fine dust from the pulverized impact site, was lofted high into the stratosphere. This was not a reflective chemical veil like the one from a volcano. This was a thick, choking, opaque blanket of physical matter, a funeral shroud of the Earth's own making. Sunlight, which had easily passed through the volcanic aerosols, was now met with an impenetrable wall of fine-grained soot. Within hours or days of the impact, the sky would have grown dark. Not twilight, but a profound, near-total blackness, a night that had fallen in the middle of the day, and a night that would last for years. Under this oppressive canopy, photosynthesis on a global scale would have ceased almost instantly. The foundation of nearly every food chain on the planet was severed at its root. Plants withered, phytoplankton in the oceans died off. Herbivores starved first, followed swiftly by the carnivores that hunted them, including the mighty Tyrannosaurus rex. The darkness was accompanied by a chilling cold, an impact winter far more severe and sudden than its volcanic counterpart. The world was plunged into a state of suspended animation, a cold, dark and silent epoch where survival was measured by one's ability to endure the long night. This is the true cosmic threat, not a distant ephemeral comet casting a mythological shadow, but the brutal physical reality of a kinetic impact, a cosmic guillotine that severs the link between a planet and its star. The phantom of Comet Atlas has vanished, dispelled by the inescapable light of reason. Its 3 days of darkness were a fiction, a story we told ourselves, but in its place stand two titans of destruction, one born of planetary fire, the other of cosmic collision. These are the true engines of global night, the authentic mechanisms that can bring about a world without a sun. And their stories are not myths, they are warnings etched into the very rock beneath our feet and written in a thin layer of iridium-rich clay that encircles the globe. They are waiting for us to decipher them before the sky has a reason to fall again. So while the silent passage of an interstellar wanderer like 3IATLAS captures our modern imagination, a chilling truth remains etched into the deep history of our world. The greatest threats of profound world-altering darkness have never come from the void between the stars. They have always been born from the fury of the Earth itself, or from the violent geometry of our own solar system. The prophecies of a brief 3-day twilight, however terrifying, are a comforting fantasy compared to the geological reality. To truly understand what it would take to extinguish the sun, we must move beyond speculation and step into the heart of the cataclysm. We must witness the raw physical mechanics of how a planet's light is put out not for days but for years, for decades. Our first journey takes us deep underground, beneath the stunning landscapes of our most beloved national parks, to a place where a continent's worth of molten rock churns with unimaginable pressure. Here, in the virtual realm of our most powerful supercomputers, we can watch the planet's ultimate weapon arm itself. This is not a mountain that erupts. This is a whole section of the Earth's crust waiting to fail. We call it a supervolcano. The signs when they begin are subtle, easily dismissed as the planet's usual groans and sighs. A swarm of tremors too deep to be felt, but registered on seismographs as a frantic rising hum. The ground itself begins to breathe, swelling by inches, then feet, as the immense magma chamber below pushes relentlessly upward. Geysers that have been reliable for centuries suddenly falter, their plumbing choked and superheated before exploding in violent steam flashes. This is the Earth's fever, the final warning before the delirium, and then it happens. Our simulation renders the moment with terrifying clarity. A single point on the surface gives way, and the pressure difference between the magma chamber and the atmosphere triggers a decompression event of incomprehensible scale. It is the planet uncorking itself. The initial blast isn't fire. It's pulverized rock propelled upwards by expanding gas at 3 times the speed of sound. It punches a hole through the sky, ejecting a column of ash and debris that doesn't just reach the stratosphere. It rips through it, soaring 50 kilometers high to the very edge of space. The sound wave from this explosion circles the globe multiple times, a deafening planetary gong announcing the start of a new dark age. Within minutes, the beautiful pillar of cloud collapses under its own immense weight, racing outwards in all directions. This is the pyroclastic flow, a ground-hugging avalanche of superheated gas and ash, moving at hundreds of kilometers an hour, sterilizing everything in its path for a 1,000-kilometer radius. It is an incandescent grey tsunami that vaporizes forests, boils rivers, and entombs cities. But the true weapon of this cataclysm is not the immediate localized destruction, it is the material injected into the highest reaches of the atmosphere. The simulation now shifts its focus, tracking the insidious spread of the real agents of darkness. We see the finest particles of volcanic ash, shards of microscopic glass catching the high-altitude jet streams. These winds, the circulatory system of our planet's weather, become the couriers of twilight. Within 48 hours, the first hazy grey veil appears in the skies of neighbouring continents. The sun, once a brilliant gold, is reduced to a tarnished silver coin, its warmth already fading. This is the onset, and here is where the 3-day prophecy utterly dissolves against the brutal physics of our atmosphere. It is not the ash alone that will seal our fate. It is the sulfur. Millions of tons of sulfur dioxide gas, invisible and deadly, have been hurled into the stratosphere. High above the clouds, far beyond the reach of rain that could wash it away, a devastating chemical reaction begins. Sunlight itself powers the transformation, converting the gas into a thick, persistent haze of sulfuric acid aerosols. These droplets are infinitesimally small, yet they are extraordinarily effective at reflecting sunlight back into space. Our simulation visualizes this process not as a cloud, but as a mirror being assembled piece by piece over the entire planet. Within 2 weeks, the process is complete. The sky is no longer blue or even grey. It is a uniform, oppressive ceiling of milky white, and beneath it, the world is plunged into a perpetual freezing twilight. The sun is gone, not obscured as if by a passing storm cloud, but fundamentally erased from view. The darkness has arrived, but it is a darkness coupled with a cold that begins to bite with an unnatural ferocity. The planetary temperature drop is not gradual. It is a precipitous, shocking fall. Within the first month, global average temperatures plummet by 5, then 10 degrees Celsius. In the heartlands of North America and Eurasia, this translates into a summer that never arrives. Snow begins to fall in July, over grain belts that are supposed to be feeding billions. The effect on our civilization is immediate and total. The delicate web of photosynthesis, the foundation of nearly all life on Earth, is severed. Plants starved of light can no longer convert carbon dioxide into energy. The great forests of the world begin to wither their leaves, turning a sickly yellow before dropping to the forest floor, creating a tinderbox of dead biomass. But the most catastrophic failure is our agriculture. You are watching the end of food. Fields of corn, wheat and rice, the staples that sustain our global population, fail on a planetary scale. They are first stunted by the cold and the acid rain, then starved by the lack of light. The harvest never comes. In the oceans, the phytoplankton, the microscopic organisms that form the base of the entire marine food web and produce half the world's oxygen, die off in the darkened surface waters. The seas, once teeming with life, begin to clarify into sterile blue deserts. The cascading collapse is swift. Herbivores starve first, then the carnivores who feed on them. For humanity, the world's grocery stores empty in a week. Strategic grain reserves, which seemed so vast, are now revealed to be pitifully inadequate for a crisis with no end in sight. The initial chaos you might imagine riots, looting is just the overture. The true horror is the silence that follows the quiet, desperate reality of global famine. Governments built on the premise of growth and stability are rendered powerless. Borders become meaningless lines on a map as desperate populations begin to move, seeking warmth and food that no longer exist anywhere. This is not a 3-day event. The stratospheric aerosol layer is stable. It will take 30, perhaps 50 years for these particles to slowly, imperceptibly fall out of the sky. For a human lifetime, the world will be trapped in a volcanic winter, a long, desperate struggle for survival in a cold, grey, dying world. Now let us reset the simulation. We pull our perspective away from the Earth, out into the silence of the solar system. Here, another agent of darkness keeps its vigil. It is not born of our world, but it has our world's name on it. We are tracking a rock 10 kilometers wide, a jagged mountain of nickel, iron and silicate hurtling through the void at 20 kilometers per second. It is a leftover piece from the formation of the planets, and its random intersecting orbit is about to end 4.5 billion years of wandering. This is the second path to darkness, a path of even greater violence and speed. As the asteroid enters the upper atmosphere, it becomes a celestial blowtorch, compressing the air in front of it into a plasma hotter than the surface of the sun. From the ground, for the few seconds before impact, it would appear as if a second sun had ignited in the sky, a beautiful, silent, terrifying star, growing impossibly bright. The impact itself is almost beyond visualization. The moment it strikes, the kinetic energy released is equivalent to 100 million megatons of TNT. The entire world's Cold War nuclear arsenal detonated at a single point 1,000 times over. It does not leave a crater so much as it liquefies the planet's crust, creating a transient hole over 100 kilometers across and 30 kilometers deep. A wave of superheated rock and plasma expands outwards, vaporizing everything for a 500-kilometer radius in less than a minute. The seismic shock is registered on the far side of the planet as a magnitude 12 earthquake, triggering volcanic eruptions and landslides globally. But again, the true darkness is delivered through the atmosphere. The simulation shows us the first mechanism. Trillions of tons of pulverized and molten rock are ejected from the crater on ballistic trajectories, flying high above the atmosphere before arcing back down across the entire globe. As these countless tiny meteors re-enter the atmosphere, the friction heats them to incandescence. For several hours, the entire sky of planet Earth everywhere is lit up like the inside of a blast furnace. The radiant heat at ground level is intense enough to ignite any flammable material. Global wildfires consume the world's forests, releasing a staggering volume of smoke and soot. It is a planetary-scale firestorm. And it is this soot that becomes the primary agent of the second great darkness. Unlike the reflective aerosols of a volcano, soot is black. It is a near-perfect absorber of light. Our simulation shows this thick, greasy layer of carbon black rising from the continental fires and spreading through the upper atmosphere. It joins the fine rock dust thrown up by the initial impact, creating a compound shroud of unparalleled opacity. The darkness that descends is faster and far more profound than the volcanic twilight. Within days, the amount of sunlight reaching the surface drops to less than 1% of normal. The midday sun is not just dimmed, it vanishes completely. It is a blackness so absolute that you could not see your own hand in front of your face. It is the darkness of the deep ocean abyss brought to the surface of the world. The ensuing impact winter is therefore more severe. With the sun's energy almost completely blocked, the plunge in temperature is immediate and catastrophic. The continents freeze, the surface of the oceans choked with dust and acidified by chemical reactions in the atmosphere. The result of the vaporized rock reacting with nitrogen and oxygen becomes a toxic, frigid soup. Once again, photosynthesis halts instantly, this time on a scale that triggers a true mass extinction event. The dinosaurs experienced this exact scenario. It was the long, cold, dark years that followed the impact that truly sealed their fate, erasing them and 75% of all species on Earth. For our civilization, the outcome would be even less in doubt. The initial impact, the firestorm, the tsunamis, these would kill billions in the first 24 hours. But the handful of survivors would emerge from their shelters into a different world. A frozen, poisoned alien planet shrouded in an impenetrable blackness where the very air is toxic, and the concept of a growing season is a forgotten memory from a lost epoch. The physics of this darkness is unforgiving. The soot and fine dust lofted high into the stable stratosphere would remain for a decade, perhaps more. The slow return of the sun would be a process taking generations. So whether the mechanism is the fury of the planet from within or a violent visitor from without, the result is a chillingly similar endpoint. The intricate, delicate systems that maintain our world of light and life are severed. The darkness that follows is not a brief, terrifying interlude from which we emerge blinking into the light. It is a new, enduring state of being. It is a fundamental reset of the planetary clock, a long night that our species, with its fragile dependence on a stable climate and a predictable sun, is simply not built to survive. We have seen what it truly takes to black out the sky, and it has nothing to do with 3 days. It has everything to do with millennia. Faced with such cosmic and terrestrial titans, it would be easy to surrender to a sense of profound insignificance, to accept our fate as mere spectators at a drama written on a scale we can scarcely comprehend. The energies that carve calderas and hurl mountains through the void are so far beyond our own experience that they feel like the work of vengeful gods, not predictable physics. And for much of our history, that is precisely how we treated them. We were passive victims waiting for the sky to fall or the ground to split open. But that age is ending. We are no longer simply waiting. We have begun a new journey, not upward into the heavens, but downward into the intricate details of our own defense. This is the story of humanity's refusal to remain helpless, a chronicle of our first tentative steps to build a shield against the inevitable. It is the story of looking down at the monitors, at the data streams, at the engineering blueprints, and at the very ground beneath our feet, listening for the whispers of a coming storm. Our first line of defense is light itself, captured and dissected by a global network of silent, sleepless sentinels. For decades, the search for near-Earth objects was a scattered and underfunded affair driven by a handful of dedicated astronomers. But the growing awareness of the threat has forged a new coordinated discipline, planetary defense. At its heart in the United States is NASA's Planetary Defense Coordination Office, a name that sounds like science fiction but operates with the deadly seriousness of a global emergency service. This office doesn't command laser cannons or armadas of spaceships. Its power is something far more crucial in this initial stage of our defense information. It acts as the central nervous system for a worldwide web of observatories, a command center that verifies threats, coordinates follow-up observations, and communicates with governments and the public. It is the sober, authoritative voice that must one day cut through the noise of panic and deliver the unambiguous truth, whether that truth is a reassuring all clear or a countdown to impact. This global watchtower relies on its eyes, and those eyes are constantly improving. Systems like the Catalina Sky Survey in Arizona and Pan-STARRS in Hawaii have become our primary asteroid hunters, sweeping vast tracts of the night sky with relentless patience. Pan-STARRS, with its enormous 1.8-meter mirror and a digital camera capturing 1.4 billion pixels per image, is a brute force instrument of discovery. It photographs enormous sections of the sky repeatedly night after night. Back in its data centers, powerful software performs a colossal cosmic game of spot the difference, comparing new images to older ones. Anything that has moved against the static backdrop of distant stars is flagged. This digital net has caught thousands upon thousands of previously unknown objects, creating a catalogue of potential threats that grows with each passing day. We are for the first time mapping the hazardous traffic in our own celestial neighborhood. Yet while these massive surveys are excellent at finding the larger dinosaur-killer asteroids years or even decades in advance, they can miss the smaller, faster-moving rocks that could still obliterate a city. An object just a few dozen meters across, too faint for the grand surveys to spot until it's dangerously close, still carries the energy of a powerful nuclear weapon. This is the gap in our defenses that the ATLAS system was specifically designed to fill. ATLAS, the Asteroid Terrestrial Impact Last Alert System, is not one telescope, but a coordinated quartet with two in Hawaii, one in Chile and one in South Africa. This strategic placement gives it a panoramic view, allowing it to scan the entire visible night sky from pole to pole every 24 hours. Its mission is fundamentally different. It is not searching for threats a century away. It is our planetary burglar alarm designed to give us the one thing that might make a difference in a crisis warning time. Imagine the system at work. As the Earth turns, one ATLAS observatory hands off its watch to the next, ensuring uninterrupted vigilance. Each telescope rapidly takes 4 exposures of a patch of sky, then moves on. Back at the processing center, algorithms immediately analyze these images. The software isn't just looking for a single point of light that has moved. It's looking for a set of 4 points that form a straight line, the unmistakable signature of an asteroid streaking through our solar system. When it gets a hit, an alert is automatically triggered, flagging the object for human verification and immediate follow-up by other telescopes. This system can detect a small asteroid several weeks out and a larger one months or even years away. For a city killer, weeks of warning could be the difference between a historical catastrophe and a successful evacuation. Days of warning could mean the difference between chaos and some semblance of an organized response. ATLAS is our admission that we won't find everything decades in advance. It is our pragmatic last-ditch effort to avoid being caught completely by surprise. But our downward path of vigilance leads us from the cold vacuum of space to the molten heart of our own planet. For while our gaze is fixed on the heavens, a far more complex and perhaps more imminent threat slumbers beneath our very feet. Supervolcanoes. The name itself feels inadequate, a feeble attempt to categorize a force of nature that operates on a geological, not a human timescale. An asteroid impact is a discrete event, a cosmic bullet with a predictable trajectory. A supervolruption, however, is the culmination of a process that unfolds over hundreds of thousands of years within a vast subterranean labyrinth of rock and molten magma. It is not a single entity to be tracked, but a continent-sized system of plumbing pressure and heat whose vital signs are incredibly difficult to read. Predicting its behavior is like trying to diagnose a patient who is the size of a mountain and speaks a language of subtle tremors and faint chemical whispers. Here our instruments are not telescopes, but a different kind of sensor network, one that turns the Earth itself into a medical laboratory. At Yellowstone, the site of North America's most famous supervolcano, the United States Geological Survey maintains one of the most intensive planetary monitoring systems in the world. The first tool is the seismometer, a planetary stethoscope pressed against the Earth's crust. Hundreds of these exquisitely sensitive devices are scattered across the region listening. They are tuned to detect not just the jolts of conventional earthquakes, but the unique vibrational signatures of magma moving deep underground. They can distinguish between the sharp crack of rock breaking under stress and the low-frequency harmonic tremor of magmatic fluids resonating in a conduit, a sound that has been called the song of the volcano. A swarm of thousands of tiny earthquakes in a specific area could signal that magma is ascending, cracking the rock above it as it forces its way toward the surface. Yet seismic data alone is notoriously ambiguous. This is where another, even more precise technology comes into play: ground deformation monitoring. We are now able to measure the very breathing of the caldera. High-precision global positioning system GPS stations, anchored deep into bedrock, can detect changes in their position with millimeter-level accuracy. As the vast magma chamber miles below slowly fills and swells with new material, it pushes the entire landscape above it upwards and outwards. Over years, this movement can be measured. The ground at Yellowstone can rise and fall by several centimeters per year, a slow-motion inflation and deflation as the magmatic and hydrothermal systems underneath shift and stir. We are no longer limited to what we can see on the ground. A powerful technique called interferometric synthetic aperture radar, or INSAR, uses satellites to paint a comprehensive picture of this movement. By bouncing radar signals off the ground from orbit and comparing scans taken months or years apart, scientists can create breathtakingly detailed maps of uplift and subsidence across the entire caldera, revealing patterns of swelling that would be invisible to any observer on the surface. We can literally watch the ground warp under the strain. The third vital sign is the volcano's breath, the cocktail of gases seeping from the ground. Magma is rich in dissolved gases, primarily water vapor, carbon dioxide, and sulfur dioxide, all held in solution by the immense pressure of the deep earth. As magma rises and the pressure drops, these gases begin to bubble out like the fizz from an open soda bottle. By regularly sampling the air at vents and fumaroles, and by using airborne and satellite-based sensors, scientists can monitor the types and quantities of these gases. A sudden spike in the emission of sulfur dioxide, for instance, is a classic warning sign. It often means that a fresh, gas-rich batch of magma has risen to a shallow depth, to a potential precursor to an eruption. This chemical analysis provides a crucial window into the unseen processes happening miles below away to taste the exhalations of the slumbering beast. We are also monitoring its temperature using thermal infrared cameras on the ground and in orbit to map changes in the heat flow from Yellowstone's famous geysers and hot springs, looking for any anomalous hotspots that could signal a new pathway for heat escaping from the chamber below. Putting all this data together, the seismic tremors, the swelling ground, the shifting gas chemistry, the thermal output is the great challenge for volcanologists. There is no single eruption alarm. Each supervolcano has its own personality, its own unique rhythm of unrest. An earthquake swarm that might be a terrifying omen at one volcano could be just routine background noise at another. The Earth is constantly shifting, and the signals of an impending catastrophe must be painstakingly teased out from a constant stream of geological static. The scientists at observatories like Yellowstone are detectives, assembling clues from disparate sources looking for a confluence of evidence, a pattern of accelerating change that suggests the system is moving from its normal state of slumber towards a critical tipping point. The terrifying truth is, we have never witnessed a super eruption with modern instruments. Our models are based on the geological leftovers of ancient events and the behavior of much smaller volcanoes. We are, in a very real sense, learning the language of the monster as it sleeps, hoping we can become fluent before it ever begins to wake. This brings us to the ultimate question on our downward path. It is one thing to see a threat coming, but can we do anything to stop it? In the realm of planetary defense against asteroids, the answer is a tentative but hopeful yes. The idea is not to destroy an incoming object in a blaze of glory, a strategy that could simply turn one large bullet into a shotgun blast of many smaller, still dangerous ones. The goal is far more elegant deflection. Because we can detect these objects years or decades in advance, we don't need a massive force. We just need a tiny, precise nudge. Over the vast distances of space, a minuscule change in an asteroid's velocity, applied early enough, will compound over time, causing its trajectory to shift by thousands and eventually millions of miles. It's the difference between an impact and a clean miss. We have now proven this is possible. NASA's Double Asteroid Redirection Test, or DART mission, was a monumental achievement for humanity. It was not a weapon, it was a cosmic scalpel. The spacecraft, about the size of a small car, traveled millions of miles to its target Dimorphos, a small moonlet orbiting a larger asteroid named Didymos. It was a kamikaze mission designed to slam into the moonlet at over 140,000 miles per hour. The goal was to see if this kinetic impact, simply transferring the spacecraft's momentum to the asteroid, could measurably alter its orbit. The impact was a spectacular success, and the results exceeded all expectations. Telescopes on Earth watched as Dimorphos's orbit around Didymos shortened not by the expected 7 minutes, but by a full 32 minutes. It was a definitive demonstration. We, a species confined to a fragile planetary surface, can now reach out and move a celestial body in a predictable and measurable way. DART was our first step. Other, more advanced concepts are on the drawing board. A gravity tractor would involve parking a heavy spacecraft near an asteroid and using its tiny gravitational pull to slowly tow it off course over many years. More exotic ideas involve using focused lasers to ablate or vaporize the asteroid's surface, creating a gentle rocket-like thrust. We are no longer defenseless, we have a toolbox, and we are learning how to use it. But when we turn our gaze from the sky back to the ground, the mitigation problem becomes exponentially more difficult, bordering on impossible with our current technology. How do you deflect a supervolcano? You cannot apply a nudge to a magma chamber the size of a major city and 10 miles thick. The sheer scale of the energy involved is staggering, dwarfing the entire energy output of human civilization. Some have proposed radical geoengineering solutions. One concept involves drilling down into the sides of the magma chamber, a feat of engineering far beyond our current capabilities, and pumping in massive quantities of water. The idea would be to cool the outer edges of the magma, causing it to solidify and thereby relieve the immense pressure building within. It's an attempt to turn the volcano into a massive geothermal energy plant, slowly and safely bleeding off its heat over centuries or millennia. The risks, however, are almost as terrifying as the eruption itself. We have never successfully drilled into a live magma chamber. The temperatures and pressures would destroy any conventional equipment. Furthermore, the act of drilling into such a volatile high-pressure system could be the very thing that triggers a cataclysmic eruption. The sudden depressurization caused by a drill breach could initiate a runaway chain reaction of gas release, turning a preventative measure into the cause of the disaster we sought to avoid. Pumping in water is also fraught with peril. If it were to flash to steam too quickly, it could create a massive explosion, fracturing the rock cap that keeps the magma contained. We are talking about tampering with a system we barely understand, whose power operates on a scale that beggars belief. The heat energy within the Yellowstone magma chamber is so vast that to reduce it by the 35% needed to prevent an eruption, you would need to run a dozen of the world's largest power plants at full capacity, not for a year or a decade, but for thousands of years, just to dissipate the heat. So we find ourselves in a deeply asymmetric position. Against the threats from space, we are becoming proactive architects of our own survival, capable of seeing, planning, and now acting. But against the threats from within our own world, we remain for now little more than anxious meteorologists. We can improve our forecasting, we can issue warnings, we can prepare for the consequences, but we cannot stop the storm itself. Our downward path has led us to a place of profound humility. We have built a magnificent global nervous system to watch for danger, a testament to our ingenuity and our will to survive. Our telescopes scan the void and our sensors listen to the heartbeat of the Earth. We are no longer blind, but our vision is still imperfect, our understanding incomplete. We have taken the first tentative steps to defend our home, but we are like children learning to walk in a world populated by giants, armed with knowledge but acutely aware of our own fragility. And as we continue to watch and listen, another question begins to loom. What happens when the warning finally comes, and so we stand here on this fragile shoreline of awareness, with the echoes of ancient cataclysms still ringing in our minds? We have stared into the volcanic heart of our own planet, a furnace of unimaginable power, capable of turning day into a century of twilight. We have traced the ghost of a 6-mile-wide mountain of rock and ice as it tore through the heavens, ending a world to begin a new one. The evidence is undeniable, written in layers of ash and iridium, a permanent record of cosmic and terrestrial violence. The universe, it seems, is not a benign garden, but a wilderness filled with forces that can erase civilizations in the blink of a geological eye. It is a truth that can leave us feeling infinitesimally small, adrift in an ocean of indifferent power. The fear that arises from this knowledge is not irrational. It is profoundly human. It is the primal dread of the dark now scaled up to the celestial level. This fear, this feeling of vulnerability gives birth to the ultimate question, the one that has haunted us throughout this entire journey. Faced with the fury of supervolcanoes and the unblinking calculus of orbital mechanics, is some form of global catastrophe, some version of a darkening day, truly and absolutely inevitable? This question hangs in the air, heavy, cold. To answer it, we must first return to the catalyst of our investigation, the ephemeral visitor from the interstellar void, Comet 3I/ATLAS. We must confront the specific prophecy. It was forced to carry the vision of a world plunged into shadow by its passing. The scientific mind does not dismiss such ideas out of hand. It interrogates them. It takes the fear and holds it up to the light. So let us do just that. Let us construct this feared event in the laboratory of our imagination, guided by the unforgiving laws of physics. Imagine the comet now a memory at its closest approach. We see its tail, a magnificent but ethereal banner of dust and ionized gas stretching for millions of miles. For this tail to block the sun from our vantage point, it would need to possess an almost impossible combination of properties. It would require a density, a sheer mass of particulate matter that simply does not exist in the gossamer structure of a cometary tail. What you perceive as a brilliant cosmic cloud is in reality one of the most perfect vacuums we have ever observed. The particles within it are spread so far apart that if you were to cup 1 billion cubic miles of that tail in your hands, you would hold less material than a single grain of sand. This is the fundamental, insurmountable flaw in the scenario. We are not talking about the thick, choking, sunlight-extinguishing ash of a supervolcano which blankets the world from within our own atmosphere. That is a terrestrial threat, a planetary suffocation from the inside out. The dust of a comet exists in the void of interplanetary space 93 million miles away. To obscure the sun, a celestial furnace of incomprehensible energy with a veil so thin and so distant is a physical impossibility. It is the equivalent of trying to block out a stadium searchlight with a single puff of smoke released a mile away. The light simply punches through. The solar wind itself, that constant stream of charged particles pouring from the sun, would act as a perpetual cosmic broom, scattering and pushing these tiny motes of dust, further ensuring they could never coalesce into an effective screen. The 3 days of darkness's prophecy, when applied to the passing of a distant fragile object like Comet Atlas, dissolves under the first moment of scientific scrutiny. It is a phantom, a ghost woven from our legitimate anxieties about the cosmos, but a ghost nonetheless. The threat was never the comet's shadow. The threat was the shadow of our own fear projected onto the heavens. So one spectre is laid to rest. But does that truly answer the core question of inevitability? No. It only refines it, for we know the real dragons are out there. We have seen their footprints. The Chicxulub impactor was not a phantom. The Toba super-eruption was not a ghost. These were events of such titanic scale that they forever altered the course of life on this planet. They represent a class of threats so far beyond our everyday experience that they feel like myth. Yet they are geological and astronomical fact. A large asteroid, 10 kilometers wide or more, striking the Earth would not need a delicate tail of dust to block the sun. It would do so with brute force by vaporizing trillions of tons of the Earth's own crust. This superheated rock and debris would be blasted into the stratosphere high above the clouds, where it would encircle the globe and persist for years, even decades. This is the true mechanism of an impact winter. Sunlight, unable to penetrate the high-altitude shroud, would be reflected back into space. Photosynthesis would fail on a global scale. Food chains would collapse. It would be a darkness born not from a cosmic veil, but from the pulverized remains of our own world thrown up against the sky. This is not prophecy, it is physics, and its probability is not zero. Similarly, a supervolcano operates on the same terrifying principle, but its weapon is different. Instead of vaporized rock from an impact, its ammunition is sulfur dioxide. An eruption on the scale of Toba would inject hundreds of millions of tons of this gas into the stratosphere. There it would react with water vapor to form a fine mist of sulfuric acid aerosols. This haze is incredibly effective at reflecting sunlight, creating a chilling effect that would plunge the planet into a volcanic winter lasting for years. The sky would not necessarily turn black, but a persistent, gloomy twilight, a world without a summer where crops fail and ecosystems starve. The threat is real. The geological engines for such an event are still active, slumbering beneath our feet in places like Yellowstone, Taupo, and the Phlegraean fields. The astronomical shooting gallery is still open for business, with millions of objects tracing paths through our solar system. Statistically, over immense geological timescales, such events are not just possible, they are a certainty. The Earth has been hit hard before, and it will be hit hard again. And in that statement, we feel the chilling grip of inevitability return. If the physics are real, the threats are real, and the timeline is long enough, then are we not simply passengers on a doomed ship, waiting for the inevitable iceberg? Is our fate sealed by the cold, impartial laws of geology and astronomy? Millennia, the answer would have been a stark and simple yes. Our ancestors looked to the heavens and saw the domain of gods and monsters, a realm of immutable fate. A star falling from the sky was an omen, a portent of doom against which there was no appeal. A mountain that exploded with fire was the wrath of a deity, a punishment to be endured, not a process to be understood or mitigated. For most of our history, humanity has been a passive observer of its own cosmic condition, a child in a dark and dangerous forest, hoping only to go unnoticed. But that is no longer who we are. Something has changed. Over the last few centuries, and with breathtaking acceleration in the last few decades, we have done something no other species on this planet has ever managed to do. We have begun to open our eyes. We have started to understand the rules of the game. And in understanding, we have found the first glimmers of a new possibility, the possibility of agency. The age of passive observation is over. We have entered the era of planetary defense. This is not science fiction. It is a global, coordinated, and rapidly advancing scientific endeavor. It began not with weapons or spaceships, but with the most powerful tool we have ever devised, the telescope. All across this planet, on remote mountain peaks and in arid deserts, a network of silent, sleepless sentinels now keeps watch over the heavens. They are our eyes on the abyss. Observatories like Pan-STARRS in Hawaii and the Catalina Sky Survey in Arizona are engaged in a monumental task to map and catalogue every single near-Earth object, or NEO, that could pose a potential threat. They are not just looking for the giants, the civilization enders on the scale of Chicxulub. They are hunting for the city killers, the Tunguska-sized objects that are far more numerous. Every night these telescopes scan the celestial wilderness, capturing thousands of images. Automated software then combs through this deluge of data, searching for the faint telltale streaks of light, the tiny points moving against the fixed background of the stars. Each new detection is a question mark, a potential bullet with our name on it. Once a new object is found, the real work begins. Observatories around the world coordinate their efforts, turning their gaze to this newfound traveler to refine its trajectory. Astronomers become celestial detectives, gathering clues written in faint photons that have traveled for millions of miles. They measure its position with incredible precision again and again, night after night. Each new data point allows them to trace its orbit with greater and greater accuracy, projecting its path decades, even centuries into the future. They are building a cosmic blueprint, a map of traffic in our solar neighborhood. This is a process of slowly but surely shrinking the zone of uncertainty. A new asteroid might initially have an orbital path that shows a small chance of intersecting with Earth 50 years from now. But as more observations pour in, that path is defined more sharply. The cone of possibility narrows until in the vast majority of cases, we can say with near perfect certainty that it will miss us completely passing by at a safe distance. We are for the first time in 4.5 billion years creating a planetary early warning system. We are replacing fear of the unknown with the power of knowledge. We are trading omens for orbital mechanics, and knowledge, while powerful, is only the first step. For what is the use of knowing that a catastrophe is coming if you are powerless to stop it? For years, the answer to that question remained purely theoretical, confined to calculations on whiteboards and simulations in supercomputers. We imagined missions to deflect an incoming asteroid, but the concept felt distant, a dream for a future generation. But on the 26th of September 2022, that dream became an astonishing reality. On that day, humanity for the first time in its existence deliberately and successfully altered the motion of a celestial body. The Double Asteroid Redirection Test, or DART mission, was our first meaningful step into the role of planetary guardians. The target was Dimorphos, a small moonlet orbiting a larger asteroid named Didymos, hundreds of millions of miles from Earth. The DART spacecraft, no larger than a small car, travelled for 10 months to intercept this tiny target, a mere speck of light in even our most powerful telescopes. It was an act of audacious, almost unbelievable precision. In the final moments, autonomously guiding itself, DART slammed into Dimorphos at 14,000 miles per hour. The world watched, holding its collective breath. Telescopes on Earth and in space strained to see the result of this cosmic collision. The goal was not to destroy the asteroid, but to nudge it to deliver a tiny push, a kinetic sermon on the power of applied physics. The energy of the impact was meant to slightly alter Dimorphos' orbit around Didymos. The scientific community had predicted a change of perhaps 7 minutes in its orbital period. The actual result was staggering. The impact altered the moonlet's orbit by a full 32 minutes, nearly 5 times more effective than the most optimistic models had predicted. The cloud of debris the ejector blasted from the impact site acted like a thruster, giving the asteroid an extra powerful shove. It was a monumental success, a declaration to the cosmos that the inhabitants of this small blue world are no longer helpless. We had reached out across the void and nudged the heavens. The DART mission proved that the fundamental concept of kinetic impact works, and it works brilliantly. It demonstrated that with enough warning time, years or ideally decades, we have the technological capacity to deflect a threatening asteroid, to change its trajectory just enough so that its path and Earth's path no longer intersect. It is the ultimate expression of foresight, a planetary-scale intervention that turns a catastrophic impact into a harmless near miss. This is the turning point in our story. This is the fulcrum upon which the entire question of inevitability pivots and breaks. The threats are real, yes. The potential for devastation remains. But the narrative of powerlessness, the ancient script of doom written in the stars, is being profoundly and irrevocably rewritten. We are no longer merely inhabitants of this planet. We are becoming its stewards, its immune system. The kinetic impactor demonstrated by DART is just the first tool in what will become an increasingly sophisticated toolkit for planetary defense. Scientists are already developing and studying other methods. The gravity tractor, a concept of sublime elegance, involves parking a massive spacecraft near a threatening asteroid. The spacecraft's own minuscule gravitational pull exerted over many years would be enough to gently and precisely tow the asteroid into a new, safer orbit. For other types of threats, like the loosely packed rubble piles that DART's success hinted, Dimorphos might use focused laser ablation using the sun's own energy to vaporize small amounts of the asteroid's surface, creating tiny jets that act as thrusters to push it off course. Each of these technologies represents a new line of defense, a new chapter in our story of survival. The key, the non-negotiable requirement for any of them to work is time. Early detection is everything. Our network of Sentinel telescopes is the foundation upon which all our hopes for defense are built, and that network is growing more powerful every year. The Vera C. Rubin Observatory, soon to come online in Chile, will be a revolutionary leap forward. It will survey the entire visible sky every few nights, discovering thousands of new asteroids and comets every year. It will create the most comprehensive motion picture of our solar system ever conceived, allowing us to spot potential threats much smaller and much farther away than we ever could before. This is what changes the equation. Inevitability thrives in the dark in ignorance. It is the monster that vanishes when you turn on the light, and we are building the biggest, brightest lights imaginable. We are systematically eliminating the shadows where danger might lurk, replacing cosmic chance with deliberate choice. So we return finally to the heart of the matter. Is a darkening day inevitable? If by that you mean the specific prophetic vision of a comet's tail blotting out the sun, the answer is an unequivocal no. The laws of physics themselves stand as a sentinel against that particular fear. But if you ask whether a catastrophic impact or a super-eruption is an unavoidable part of Earth's deep future, the answer becomes far more nuanced and ultimately far more hopeful. Without us, yes, it would be inevitable. The planet would simply follow the geological and astronomical cycles that have governed it for eons. But we are here. We represent a new variable in the cosmic equation, a conscious, intelligent force that can comprehend the risks and invent the solutions. The real climax of our story is not an explosion in the sky or a rumble from beneath the Earth. It is the quiet, steady, and relentless application of the scientific method. It is the global collaboration of thousands of minds working together to see farther, understand more deeply, and act more wisely. True inevitability is not our fate, because inevitability is a conclusion, and our journey of discovery has only just begun. The power to ensure our own survival no longer rests in the hands of fate, but squarely, and for the very first time in our own. Our long journey through the shadow of fear is now complete. We began in the flickering firelight of ancient memory, with whispered prophecies of a sun that would vanish, and a world plunged into an inescapable, suffocating dark. This primordial terror, the 3 days of darkness, was a spectre born of helplessness, an expression of our profound vulnerability in a cosmos whose whims we could neither predict nor comprehend. For millennia, we were passive observers, spectators to a celestial drama in which we were merely the fragile audience awaiting a final curtain call we were powerless to prevent. The story of a comet like 3IATLAS was for our ancestors not a matter of orbital mechanics, but of divine judgment. It was an omen, a harbinger, a terrifying messenger from the gods, and its passage would have been met with prayer, with sacrifice, with resignation. But we are not our ancestors. The path we have travelled together, from the heart of that ancient dread to the pristine clean rooms of modern space agencies, marks the single greatest transformation in human history. The shift from being subjects of the universe to becoming its students and now increasingly its custodians. We have stared into the same abyss they did, but we have done so with mirrors polished by inquiry and lenses ground by mathematics. The darkness they feared as a supernatural curse we have illuminated with the steady, unwavering light of scientific understanding. What we have discovered is that the universe is not malicious, merely indifferent. Its grand clockwork motions unfold on scales of time and energy that dwarf our ephemeral existence, governed by the same physical laws that hold our own world together. The threat is not a punishment, but a probability. The danger is not a monster, but a mass of ice and rock on a collision course with our home, a problem of physics, and therefore a problem with a physical solution. This revelation is the cornerstone of our modern age. It is an intellectual inheritance more precious than any monument, a paradigm shift that has armed us with something more powerful than any ritual or appeal to the heavens' knowledge. And with that knowledge comes a profound and heavy responsibility. The spectre of an impactor, the very real possibility of a darkened sky, is no longer an occasion for panicked despair, but a summons to action. It has become a unifying challenge, a common denominator for a species so often fractured by borders, beliefs, and histories. Because the sky belongs to no one nation. A comet does not recognize our flags. An asteroid does not respect our treaties. An impact is a planetary event, and its prevention must therefore be a planetary endeavor, the ultimate expression of our shared identity as Earthlings. We have witnessed the birth of this new consciousness. We've seen it in the quiet, methodical work of astronomers across the globe, from the high, dry deserts of Chile to the volcanic peaks of Hawaii, all part of a silent global network of sentinels. Their telescopes, our collective eyes on the cosmos, are constantly scanning, cataloguing, and tracking these celestial nomads. Every new discovery, every refined orbit is not hoarded as a national secret, but shared instantly across a network of institutions like the Minor Planet Center and NASA's Planetary Defense Coordination Office. This is a collaboration born not of formal treaties alone, but of a shared scientific ethos, a recognition that in this particular arena, competition is a luxury we simply cannot afford. When a new object is detected, a symphony of observation begins, with astronomers on every continent working in concert to paint a complete picture, their combined efforts narrowing the cone of uncertainty, transforming a vague statistical summed risk into a well-defined trajectory. This global immune system, this planetary defense reflex, is still in its infancy, but it is growing stronger every single day. Its power lies not just in hardware, but in the bedrock of scientific literacy. An informed public, a population that understands the difference between a far-flung comet on a stable multi-millennium orbit and a genuine, potentially hazardous asteroid is our greatest asset. Because in a moment of true crisis, the battle will be fought on two fronts. One will be in space, with engineers and mission controllers working to deflect the object hurtling towards us. The other, equally critical, will be here on the ground, in our communities, in our news feeds, and in our own minds. It will be the battle against misinformation, against fear-mongering, against the impulse to retreat into the very same superstitious dread that paralyzed our ancestors. To win this second battle, we need more than just good science. We need excellent science communication. We need leaders, educators, and journalists who can convey complex truths with clarity and honesty, who can manage public anxiety without condescension, and who can empower people with facts, not placate them with fantasy. Distinguishing a credible threat from a sensationalist headline, understanding the nuances of probability, and trusting the methodical process of science, these are no longer abstract civic virtues. They are essential survival skills for a technological civilization that has become aware of its own cosmic fragility. This awareness, this vigilance, is now being encoded into our technology, forged into the very machines we are sending to the heavens. What we have built so far is merely a prelude. The next generation of cosmic sentinels is already taking shape, destined to grant us a level of foresight that was pure science fiction only a few decades ago. Soon, the Vera C. Rubin Observatory in Chile will begin its decade-long survey, a monumental undertaking to create the deepest, widest movie of the universe ever produced. Its colossal 3.2 gigapixel camera, the largest ever constructed for astronomy, will scan the entire visible southern sky every 3 nights. Think of it not a series of static snapshots, but a living, breathing map of the cosmos in motion. Within this unprecedented flood of data, this digital river of starlight, we will find the faint, moving pinpricks of countless new objects. The observatory's algorithms, powered by artificial intelligence, will sift through petabytes of information, flagging anything that moves, anything that changes, anything that warrants a closer look. It will be an early warning system of unimaginable power, capable of detecting threats that are smaller, darker, and farther away than anything we can systematically find today. It will push our horizon of awareness deeper into the cosmic ocean, giving us the one resource that is more valuable than any other in a crisis time. Years, even decades of advance warning. But we cannot watch from Earth alone. Our planet's atmosphere, the very air that gives us life, blinds us to certain dangers, and asteroids can approach from the direction of the sun, hiding in the brilliant glare that makes them almost impossible to spot from the ground. To cover this celestial blind spot, we must go into space. And so we are. NASA's NEO Surveyor is a dedicated hunter, a purpose-built infrared space telescope designed to operate from a point of gravitational stability between the Earth and the Sunday. Freed from the distortion of our atmosphere and the day-night cycle, it will relentlessly scan the inner solar system. Using heat-sensing infrared detectors, it will be especially adept at finding the dark, carbon-rich asteroids that reflect very little sunlight, the stealthy wanderers that optical telescopes can easily miss. NEO Surveyor is not an experiment. It is the next logical step in planetary defense, the equivalent of posting a permanent guard on the most challenging frontier. Its deployment will represent a maturation of our species, a tangible commitment to taking responsibility for our own cosmic neighborhood. Yet detection is only the first half of the equation. Knowing a threat is coming is not the same as being able to stop it. Our successful DART mission, the glorious pinpoint strike on the asteroid Dimorphos, was a shot heard round the solar system. It proved unequivocally that we have the power to move worlds. But that kinetic impactor, a cosmic battering ram, is just one tool in our growing arsenal. The future of planetary defense will be a suite of more subtle, more sophisticated options, each tailored to the specific nature of the threat we face. Imagine a different kind of mission, one that requires not brute force, but persistence. We call it the gravity tractor. A massive spacecraft would be sent to fly alongside a threatening asteroid, not touching it, but maintaining a precise formation for months or even years. The spacecraft's own minuscule gravitational pull, its tiny whisper of mass, would ever so gently tug on the asteroid. Over vast timescales, this infinitesimal persistent nudge is enough. It's the ultimate expression of cosmic leverage, a gravitational shepherd patiently guiding a billion-ton stray sheep onto a new, safer path, altering its arrival time at Earth's orbit by just a few crucial minutes, enough for our planet to have safely moved out of the way. For other scenarios, we might need a more active approach. Engineers are refining concepts for laser ablation. A powerful laser, either on a nearby spacecraft or potentially even based on Earth, would be focused on a small spot on the asteroid's surface. The intense heat would vaporize the rock, turning it directly into a jet of gas. This jet pushing off the surface acts like a tiny continuous thruster. It's a celestial blowtorch not meant to destroy the object, but to methodically and precisely sculpt its trajectory over time, pushing it puff by puff out of harm's way. This is not warfare against the cosmos. This is celestial engineering, a delicate art performed on a grand scale. It is the application of our deepest understanding of physics to ensure our own survival, a testament to the power of a species that has learned to rewrite its own fate among the stars. These technologies, from advanced observatories to gravity tractors, are more than just clever machines. They are the physical embodiment of our hope. They are monuments to our ingenuity, built not out of fear but out of a profound and abiding love for our world and for the future of our species. They are the tools we are building to ensure that there are always future generations to look up at the sky in wonder. And so we find ourselves back where we started looking up. But our gaze is different now. It is not the fearful, uncomprehending stare of our ancestors. It is the focused, informed gaze of a civilization that has come of age. We understand now that the universe is a place of breathtaking beauty and of profound, humbling danger. The vast, silent darkness between the stars is not empty. It is filled with the echoes of creation, with wandering worlds, with the raw materials of life, and with the potential for both wonder and destruction. Our challenge is to navigate this cosmic duality with wisdom, with courage, and with foresight. The myth of the 3 days of darkness taught us to fear the sky, but our journey through science has taught us something far more powerful. It has taught us that the only darkness we truly need to fear is ignorance. The only night that can truly defeat us is the one that falls when we stop asking questions, when we cease to explore, and when we turn our back on the rational, collaborative pursuit of knowledge. The light that holds that darkness at bay is not the sun alone. It is the incandescence of the human mind. It is the collective brilliance of our science, the warmth of our collaboration, and the unwavering flame of our curiosity. As long as we tend to that flame, as long as we continue to reach for the stars, not as supplicants but as explorers, we have nothing to fear from the dark. The cosmos has bequeathed to us a magnificent, fragile home. Our ascension to sentience, our slow crawl from the primordial oceans to the threshold of interplanetary space, has given us the unique ability to be the guardians of this world's incredible story. We are the custodians of a 4 billion-year-old biological legacy. Protecting that legacy is the great unifying work of our time. While the universe is full of immense and unpredictable power, humanity is no longer a helpless child cowering in the night. We are awakening, we are learning, and we are building a future where our continued existence is not a matter of chance but a matter of choice. We are choosing to see. We are choosing to understand, and we are choosing to act together, securing our precious place in the sun, not just for 3 more days, but for generations to come.